Okay, so a polyhedron, you may have heard that word before, have you? Polyhedron? It's a 3D shape with like flat surfaces and flat edges. Like this is a polyhedron. So that's what we're gonna write. Solid with flat surfaces. I'm going to limit the amount of drawings that you actually do because the drawings don't come out well. So if I'm referring to something, I'll just show you what I'm talking about. Regular polyhedrons, just like regular polygons, are like perfect. So in a regular polyhedron, all the faces are regular congruent polygons. An example of this would be like a cube. In a cube, all the faces of the cube are the exact same dimensions. They have the same area. All 6 sides are the same square. Two examples of polyhedrons are prisms and pyramids. Prisms have 2 parallel congruent bases. So you have rectangular prism, triangular prism. And just like on this triangular prism, the triangles here are the exact same dimensions. So if you have the area of one triangle, you have the area of the other triangle. They're congruent. And pyramids, there's many different kinds of pyramids. Here are the most common ones: triangular pyramid, square pyramid, and rectangular pyramid. I know you probably have a picture of what a pyramid looks like in your head, like the pyramids in Egypt. This shape specifically is the shape of the base. So for a triangular pyramid, the base would be a triangle, and then of course it comes together to a point like you're used to. Square pyramid has a square base. A rectangular pyramid would have a rectangular base. Some examples that aren't polyhedron would be anything with curved surfaces or edges. Is that everyone? Yes. I'm sure there's maybe a few coming in. Thank you. Thanks. Okay, so one example would be a cylinder. This is not a polyhedron because it has curved faces, curved edges. A cone is a non-example as well. And a sphere is a non-example. Volume is the space inside a solid figure. And then surface area is the area of the surfaces of a solid figure. Area of the now we're going to move on to the equations that we'll use in this lesson. Let's see, ready? Okay. Now on the next page, we're going to fill in the rest of the equation page. Okay. You can get it at the end, okay? So we're going to start out with volume. This should be review for a lot of you. This is covered thoroughly in 6th, 7th, and 8th grade. After the couple lessons this morning, I realized that it wasn't covered as thoroughly as it should have been in middle school. So just stick with it. We're going to spend more time on this throughout the year, so if you get too stuck, don't stress out about it. I realize that some of you, this is review, some of this is like, I've never seen this before. So wherever you're at, I understand. As far as volume, we're going to look at like 3 different categories. The first one includes a rectangular prism, triangular prism, and cylinder. Even though these are very different looking shapes, they use the equation for volume that looks like this. Volume equals area of the base times the height. I'm going to explain that a little bit more in depth. Okay, so for a rectangular prism, which is the first shape listed there, to find the volume of this or the space inside the shape, you're going to find the area of the base and then multiply by the height. Now the area of the base here is a rectangle, so you would use length times width to find the area of this and then multiply by the height. Pretty simple. If you were trying to figure out how many pieces of candy were in this, like M&Ms or jelly beans, you could count the number of jelly beans on the bottom and then count the number of layers, and you would find how many jelly beans are in this shape. And that's what we're kind of doing with volume, only with cubes. So that works for this. The same idea works for a triangular prism or any prism, because for a prism you have to have 2 congruent bases and they're connected by these rectangles here. So to find the volume of this, you could again count the number of jelly beans on the bottom, then count the layers of jelly beans, multiply those 2 numbers, and you'd have the number of jelly beans in this thing. So when we find the area of this, of the base of this, we use the area of a triangle because that's the shape. So it would be base times height divided by 2 to find the area of this base. And then you just multiply by the height. The same actually works for a cylinder as well, because again, you have the base, which is a circle, and then you find the area of the base and multiply by the height. Only difference is now you're working with a different equation for a circle. So you'll have to, for this equation, grab the area of whichever shape you're working with, find the area of the base, then multiply it by the height of the shape. Makes sense? Kinda? Okay, we'll practice it too. Okay, so then the next group of shapes is going to be cones and pyramids. So a cone looks like this, and a pyramid. The equation for volume of a cone or a pyramid is volume equals 1/3 area of the base times the height. So in these equations, the capital B isn't a specific number until you calculate it. So whatever the base is, so for a cone it would be a circle, for a pyramid it might be a square or a triangle, you have to find the area of that base first. It is similar to this equation over here, but the difference is you're dividing by 3 at the end, or multiplying by 1/3. So you'll find the area of this base, so if you found the area of the circle, and then multiply by the height, you'd be finding all of this area around it, which would be too much. So somebody figured out that this is 1/3 of that entire cylinder. So all you do is you divide by 3, and then you have the volume of the cone. Same with a pyramid. You find the area of the base. Again, depending on what that shape is, that calculation will change a little bit. Multiply by the height, and then divide by 3. And then you'll find the volume of just the pyramid. Next, for a sphere. This, we're just a simple equation. Well, maybe not simple equation. 4/3 pi r cubed. To solve that, you'd start by cubing the radius using order of operations. As far as putting this in a calculator, you would do 4 divided by 3 to get 1.3 repeating, times 3.14 times whatever this number came out to be. And surface area. Surface area, each one of these shapes has a very specific equation to find the surface area. If you're looking for a very specific equation, on the back of your syllabus, there are these specific equations. These equations aren't on the reference sheet for the FSA, so therefore, if you wanted to use these equations, you'd have to have them memorized, which probably isn't realistic for most of you. So instead, we're going to learn the concept of surface area, and then you can use the concept to find surface area of a shape if needed. So for surface area, we're going to flatten the sides. The concept for surface area is the area of all the faces. So for a rectangular prism, which is where we're going to start, we're going to flatten the sides to create what's called a net. So if I was to draw the bottom of this, I would draw a rectangle. Then if I was to fold out these two sides, I would draw a rectangle here and a rectangle here. Then I'm going to fold out this side here. The other side, and I have one face that I'm missing, and that's the top. Now if I had this all flattened out and folded out, there would be one more right here, which would be the top. Now to find the surface area of a rectangular prism, you'd find the area of each rectangle and then add that to find the surface area. Triangular prism, again, we're going to now be working with this shape, and we're going to flatten this one out. The bottom is a rectangle. You can fold out the triangles this way. And then these two sides are rectangles as well, so we'll fold it out here and here. So to find the surface area of a triangular prism, you'd find the area of the triangles and the area of the rectangles, and then add those areas up. Cylinder, a little bit different. Here is a cylinder-ish shape. A cylinder has a circle on the bottom and the top. The circles are the exact same dimensions, so they have the same area. Around the sides of a cylinder, I don't know if you can visualize this, it's a rectangle. So if I was to take a piece of paper and like put it around the cylinder, it's a rectangle. So when we flatten it, we have a rectangle and two congruent circles. So to find the surface area of this shape, you would find the area of one of the circles, and that has to be the area of the other circle, and then you would find the area of the rectangle. The length here would be the height of that cylinder, and then this here, this distance, is the circumference of the circle, because remember, it's going all the way around that top. So this distance of the rectangle is circumference. you'd have to multiply circumference by the height to find the area of that rectangle. Okay, and cone. We're going to stick to the equation for this one. The equation is and the equation for surface area of a sphere is this. And then pyramid, we're going to show a flattened version of a pyramid. If a triangular pyramid has a triangle base, then we're going to start with the triangle base. And then there would be 3 triangles off that base. And if you found the area of all of the triangles, you could add that up to find the area, surface area. And if you had a square pyramid, it would have a square base with 4 triangles. Okay, now we're going to practice this in the workbook.